head over to Schoology and click on Chapter 15 Lesson 2 notes, sign in and edit them so that you can follow along with this presentation. Today we're going to be talking about what electricity is and how it's produced, which is Chapter 15 Lesson 2. Just to remind you, we finished Chapter 14 where we talked about potential and kinetic energy, and then we moved on to Chapter 15 after talking about light as one source of energy. We talked about heat and electricity, and we just finished up a lesson on thermal energy and how it's transferred. Now we're going to take a look at another type of energy, which is electricity. So we're going to see again how electricity is produced and what it is. Then we're going to take a look at a circuit and what it is, and that relates to electricity. So let's go ahead and jump into what electricity is. There are two words to know, the first of which is static electricity. And static electricity is the electric charge that builds up on an object that has gained or lost electrons. So make sure you write that down. Current electricity is the flow of electric charge through a wire. More about static electricity. It's the buildup of an electrical charge on the surface of an object. It's called static because the charges remain in one area. That's an important distinction. The charges remain in one area. Let me back this up a second. So the other type that we just looked at again is current electricity, and that's the key difference. They don't move anywhere in static electricity, but in current, they're going to flow like the current of a river. If you've ever pictured a river flowing, it goes somewhere. Like, I don't know if you've ever seen it rain hard on your sidewalk and you've seen a current going one way down the stream, or down the street, I should say, as the water rushes toward the grate to go down into the sewer or whatever. You might see a ball or some trash riding on the water as it goes that way, because the current is carrying it. It moves. That's not the case with static, but it is the case of current electricity. We see static electricity every day. It can even build up on us. For example, when we rub our feet on the carpet, I don't know if you've ever done that, you can zap something when you touch it. That's static electricity that we build up on the surface of our skin, discharging onto another object. We also see it when our hair gets charged, like so up here. Let me change this again. You see this gentleman's hair is standing up. And when our pants stick straight up, not our pants, when our pant legs keep sticking to our legs is what I meant to say. That's another example of it. When you get the pants out of the dryer, they tend to have some static on it. All right, let's take a look at more static information. In our study of atoms, we learned that atoms are made up of tiny particles called neutrons, protons, and electrons. The neutrons and protons make up the nucleus. The electrons spin around the outside of the nucleus. A static charge is formed when two surfaces touch each other and the electrons move from one object to another. One object will have a positive charge and the other a negative charge. And again, we're going to watch a video in just a minute on this, so if it's kind of hard to picture, just wait for the video. Rubbing the items quickly, like when you rub a balloon fast over something or your feet on the carpet, will build up a large charge. Items with different charges, positive and negative, will attract, while items with similar charges, positive and positive, will push away, or sometimes we call that repel. They'll repel each other, sort of like a magnet would. All right, so two examples. The first one is when you slide down a slide, like a metal slide at a park. I don't know if you've ever gone down that. Even a plastic slide will work when you climb up to the top and then you sit down and you go down the slide. You might have a static charge build up and your hair stands straight. This is because the friction of sliding has caused a positive charge to be built up on each hair. And since the hair is the same charge, they all try to push away from each other and end up standing up straight. Another example is when your skin is charged with static electricity and you touch something metal, like a door handle. The metal is very conductive and will quickly discharge the static electricity, creating a zap or small spark. Does it have any real uses? Does static have any real uses? Yeah, it does. Static has several, also called applications in the real world. One is with printers. So we can definitely use it with printers or photocopiers, where static is used to track the ink or toner to the paper. Other uses include sprayers, air filters, and dust removal. I don't know if you've ever seen one of these dusters. Let me get an example up here. Have you seen one of these before? Those are definitely well known for dusting, but they use static to collect the dust. On the flip side, there can be some negative results of using static or dealing with static. It can also cause damage. Some electronic chips, like the kind that are in computers, are very sensitive to static electricity. There are special bags to store electrical components in so they don't get destroyed by static. Also, people that work for these kinds of electronics wear special straps that keep them grounded. We'll take a look at that word in just a minute, but it's not when you get in trouble. This kind of grounding keeps them connected to the ground, and that's so they won't build up a static charge and ruin the electronic components. So I'll show you what I'm talking about here. This is a wire, a ground wire. There are always several wires when you have a wire that runs to a light bulb or any fixture or electronic device that has wires. Here's another example of that copper ground wire. And then if you've seen a plug that doesn't just have two, but three prongs, the third prong is ground. And again, that just lets the extra electricity or current or charge flow into the ground to keep it from damaging anybody or anything. So that's what they're talking about when they talk about keeping it grounded. Fun facts about static electricity. A spark of static electricity can measure thousands of volts. Have you seen, let me see if I can see it. Have you seen a 9-volt battery like this before? This has 9 volts, but there could be many, many, many volts. Volts is just a way to measure electricity. Unfortunately, there's not much current, and it doesn't last for very long, so static doesn't have a lot of power or energy. Now, lightning is a powerful and dangerous example of static electricity. As dangerous as it is, only around 30% of people struck by lightning end up dying. 70% survive. So most people survive, and it's usually because they don't get struck directly, and the biggest concern is it could bother their heart, and if people give them CPR, they can come back. Now, they will have long-term negative effects potentially, but they usually survive. Temperatures in a lightning bolt can be as high as 50,000 degrees Fahrenheit. But again, it just lasts for part of a second. Static electricity will build up faster on a dry, non-humid day. All right, here's a couple videos to watch. I'm going to encourage you now just to pause the video and watch both of these. They'll be right below this video on the page. So pause and watch both of them, and then come back and continue through the slides. And finally, here's a question to think about. Now, it says think, pair, share, but all I want you to do is just think about it and then write your answer down below. You can add a text box, okay? So sometimes clouds end up with a negative charge, which you'll pick up, or you will have picked up on from the video you just watched. Here's the question. So if you have a cloud and it's got a negative charge, here my electrons, I was going to say my negatrons, but my electrons are down here, colorful as they may be. They're all built up on the bottom of the cloud. How is that going to affect the earth below? Here's a lovely tree. Another lovely tree. Okay, there are trees, but they're not lovely. Here's my mountain. How is this cloud going to affect the earth below? Go ahead and add a text box here and write out what you think your answer would be or what you think the answer is. And then that will do it for today's slideshow.